All right, let's talk about how angles are measured. This is section 11.2. Let's get started. We're going to talk about some vocabulary. We have two vocabulary words here. We have terminal ray and initial ray. When we begin drawing our angle, we start with a ray, and then we join them at a common point with the terminal ray. And the angle is the distance in there. Let's talk about how these angles are measured. If we make a complete rotation with that terminal ray all the way around, we would become one revolution, which is 360 degrees. So we can start our angle at various places and have various places it can go around. That angle could go all the way around and eventually make it back to the beginning, and that would be our 360 degrees. But why is it 360 degrees? Why isn't it 10 degrees or 25 degrees? Well, it has to do with those Babylonians. They used a number-based system of 60. We use now a 10-based system, but they used a 60. They decided to subdivide an equilateral triangle into 60 units. They noticed that an equilateral triangle, you can take 6 of them and fit them into a circle. So the 6 times 60 makes our 360 degrees that we use today. Let's talk about coterminal angles. The word co means together, and terminate or terminal means to end. So these are angles that end together. We measure triangles starting at the positive x-axis and go counterclockwise from there. If we have a 20-degree angle and we have a 380-degree angle, they will be at the same position and they will be coterminal. We measure negative angles by going clockwise. Here's our 20-degree angle that we mentioned. And if I start here and go one revolution, I will end up back at the 380 because 360, one full revolution, plus the 20-degree angle will equal the 380-degree angle. These are coterminal. We can start backwards here, and if we go backwards, we'll have a negative angle. If we went down, let's say 40 degrees, we would call this a 40-degree angle. Positive goes this way, negative goes this way. Let's do some examples from your homework. We want to know if these two angles are coterminal. So if I took the 85 degrees and I added 360 degrees, I would get 445 degrees. That does not equal the 285 that we thought it would be. So no, these are not coterminal. Let's find some coterminal angles between 0 and 360 for the 995. Notice that this is huge. This is way over 360. So what I'm going to do is I'm going to subtract 360 multiple times. I might have to do this like 2 or so times to get down to an answer between 0 and 360. So if I first subtract 995 from 360, I get 635, but we're still not between 0 and 360. So 635, if I subtract 360 again, I get 275, and now I am in range. 995 is coterminal with 635 and 275, which is in our range. Now we're going to find a positive and a negative coterminal angle for this angle given here, the negative 600. So I am going to get this down into one that's a little bit more reasonable. The 600 is quite large. But instead of subtracting 360, I'm going to add 360 since it's negative. When I do that, I'm going to get 240, but it's still negative. So I'm going to take that negative 240 and I'm going to add 360 to it again so we can get it to be a positive. And I get 120 out of that. Now, I have 120 that is a positive answer, and I have the 240 that is also negative. And so that gives me our positive and our negative. All right, we learned about degrees, that 360 degrees was in one revolution. But now we're going to learn how to measure this with a different system, the radian measure. We have a circle over here on the side, and I've drawn two radii, and we're going to call those R. The radius comes from the center out to the edge, and I've got two of them to form an angle. I've also got an angle, and we name that angle theta. This symbol here in the center is theta, and that is the measure of this angle. We also have an arc length. That arc length is the distance around the circle, and in this case, it's a partial arc length. All right, the relationship between S, R, and theta is that S equals R multiplied by theta. This will work only if theta is in radians. Now I'm going to divide both sides by R so that I'll get theta equals S over R. Let's define radians. Radians is the angle measure that results when S and R are equal. Let's now convert the degrees to radians and back. So we have to find a conversion factor. How do radians and degrees relate? If you remember back, 360 degrees was one revolution. And you know that the full circumference of a circle is 2 pi r. I have the equation that I had earlier with theta equal S over R. Now we just said that S, if we're talking about the full circumference, is 2 pi r. So right here, I'm going to bring up that S is 2 pi r divided by R, which our R is right there. We're going to reduce that right there to reduce those R, so I'll just have 2 pi. We did this for a full revolution. That means that my 360 equals 2 pi. I'm going to divide both sides by 2, and my pi radians is going to equal 180. This is the conversion factor. Pi radians equals 180 degrees. You'll need to know this so we can convert radians to degrees. We said that an angle is measured from the positive x-axis going counterclockwise. So if we go all the way around our circle, we said that was 2 pi. But what if we only go part of the circle? What if we go halfway? Well, half of 2 pi is pi. What if we don't go halfway, but we only go a quarter of the way around? Well, our 2 pi divided by 1/4 is a half pi. So this right here is half of pi. If we go 3/4 of the way, our 2 pi times 3/4 is 3 pi over 2. One thing we need to remember, that one full revolution is 2 pi radians, and our conversion factor was 180 degrees equals pi radians. Let's now convert some together. Some things that are important for you to remember is that degrees have a symbol and radians do not. If there is no symbol, you must assume that you're doing radian measure. And remember that our conversion factor is 180 degrees equals pi radians. So this has a symbol. It has the degree symbol above it, so we know it's degrees. We're going to convert this to radians. So we're going to multiply by our conversion factor. Our conversion factor is here, but when I do that, we're going to convert it so that we can cancel out those degrees. 180 has a degrees, so we put that on the bottom so those degrees will cancel. And we put pi on top. So let's reduce this. 15 goes into 180, 12 times. So this is pi over 12 radians. Remember that if we don't have to put any symbols, we're just assuming that it's radians. Let's do another one. Let's do number 11. Remember, if it's degrees, we put the 180 on the bottom so that our degrees will cancel with the pi here. My 280 over 180, we need to convert that or reduce that. Some of you have a fraction button on your calculator and some don't. I got 14 over 9, so it's 14 pi over 9. Let's now do it backwards. Let's convert radians to degrees. So we're still going to use our factor over here, our conversion factor over here, and we're going to, this time, pi here to reduce out. So we're going to put the pi on the bottom and the 180 on the top. And now we need to multiply by 3 and divide by 4. Pause this video if you need to do it on your calculator and come on back. We get 135. Don't forget to put your degree symbol. Let's do another one. Remember, we're converting from radians to degrees. We want that pi to cancel, so we're putting it on the bottom. Now, the pi will cancel, and I'm going to take 8 times 180 divided by 9, and we get, pause this video and do that on your calculator, we get 160 degrees. Let's now talk about coterminal with radians. We did a coterminal with degrees. Now we're going to do coterminal with radians. When we have an angle measure, coterminal means I'm going to go all the way around. But for degrees, that means I go 360 degrees. But with radians, it means I go 2 pi radians. So I have to find a coterminal angle between 0 and 2 pi. So I'm going to have to add the 2 pi, just like I added the 360 multiple times, until I get it between 0 and 2 pi. So the trick is, when you use your calculator to help you with this, just forget the pi for a moment. Take your negative 62 over 45 and add 2. You can convert that to a fraction. Many of you have a button to do that. And then at the end, tack on the pi. So let's do that. Go ahead and get your calculator out and do that. When I do that, I get 11 over 21. And I'm going to just tack the pi back on. 11 pi over 21. Let's now see if these are coterminal. So if I took the 3 pi over 4 and I added 2 pi, will I get the 11 pi over 4? So again, like I said before, if you want to use your calculator to help you, just forget the pi's for a moment and take 3/4 and add 2. Will you get 11 over 4? Why don't you check it out? Get your calculator out and plug it in and find out, or just get a common denominator and figure that out also. When I was done, I did get 11 over 4, and so yes, these are coterminal. They end at the same spot. Now we're going to find a positive and negative coterminal angle for this 11 pi over 6. So I'm going to add 2 pi to this, forgetting my pi for a moment and taking the 17 over 36, I'm going to add 2 to it. If you're doing it on your calculator, go ahead and get it out and do that. When I was done, I got 89 over 36, and then I'm going to tack on the pi. That's our positive, but we also needed a negative. So we're going to take 17 pi over 36, and we're going to subtract 2 pi. Go ahead and do that one also, and check back with me when you're done. I got a negative 55 over 36, and you just tack on the pi when you're done. We have our negative and our positive. Let's talk about sectors now. You've been memorizing equations for this in your Formula Madness. What is the equation for the arc length of a sector? And what is the what is the equation for the area of a sector? And what is a sector? So the formula for the arc length of a sector, we just did that a minute ago. That was the S equals R theta. And your formula for the area of a sector is A equals 1/2 R squared theta. And a sector is this little piece of, like a piece of pizza or a piece of pie. These two equations only work if your angle measure is in radians. Let's now do some examples. We're now going to find the arc length here. So if you remember, our equation is S equals R theta. And this only works if theta is in radians. And yes, sure enough, it's in radians. So we have 18 we're going to put there. And we're going to multiply that by 5 pi over 4. They want these answers to be exact. That means you're going to keep the pi as your answer. So don't do anything on your calculator with a pi. Just take your 18 and multiply by 5/4, or take 18 times 5 and divide by 4. You get, pause this video and use your calculator to find out. I got 45 over 2, and then we just tack that pi on when we're done. 45 pi over 2. Let's now do an area. We're going to remember the formula is area equals 1/2 R squared theta. We'll bring down the 1/2. Our radius is 16. Don't forget to square it. And our theta, or our angle measure, is 5 pi over 4. They want the exact answers on this, so keep the pi in your answer, but don't put it in your calculator. You're going to take 1/2, 16 squared, times 5/4. You do it and compare your answer with me. When I was done, I got 160. Now, we need to remember that this has units here, kilometers. So we need kilometers squared. And our previous question that we had was 45 pi over 2. We needed to put our units of meters on that one. All right, we're going to do some of these in our calculator. You've been doing degrees on your calculator. Now we're going to do this to radians. So make sure on your calculator you hit that mode button. You come down in here to the radians, and you pick radians here. Scroll down, because we're probably in degrees after you did them earlier. Make sure you pick radians whenever you're doing that. We're going to do cosine of 5 pi over 18. You type in a cosine, and then you type in your 5 pi over 18, hit enter. Do that one and compare with me. I got 0.6428. Make sure you give me 4 decimal places, because it says we're going to round to the nearest 10,000th. Now we're going to do the cosecant. Now cosecant is the reciprocal of sine. So in your calculator, you're going to type in 1 over sine and the 5 pi over 18. Go ahead and do it on their calculator and come compare your answers with me. I got 1.3054. We have now completed this lesson. We've studied angles. We studied their vocabulary. We studied how they were measured. We got both degree measures and we explored radian measure. We studied coterminal angles with those radians. We also found sectors, their area and their arc length. We also explored how to do radians on our calculator. I hope this has been helpful. Goodbye.